So, hello everyone. My name is Joe Tassone. I'm the Senior Systems Engineer at Moonblink, and thank you very much for joining us today with the webinar we have today called Deploying Wireless Video Surveillance Networks. If you guys have any questions, there's a Q&A button just below the right-hand corner of the screen, so you can just type your questions in there, and what we'll do at the end, we'll address the questions as best we can. Okay? So, the purpose of this webinar is just to give a general overview of what's involved in deploying a video surveillance network using wireless as the infrastructure. So we only have a half an hour. We wanted to keep it short because we know you guys are busy. So hopefully this will give you a good general idea. And if you need any more details after this webinar, we can always provide you with more information down the road as you need to. Okay, so just take a look quickly at the agenda. So what we're going to do is we're going to look at an overview of video surveillance networks, or overview of a video surveillance network rather, and different network camera options. We're going to look at analog technology versus IP. We're going to look at server-based system versus a DVR or digital video recorder system. We'll look at the video management software, the powerful tool that will allow you to tap into the cameras, and then integrating the wireless technology with it as the infrastructure so that you can deploy these using wireless. And then we'll look at the bandwidth and the storage calculation requirements, what you would need, so you get a good idea of what you would need, and make sure that the network would support the video and the cameras could provide adequate coverage to the areas that you want visibility into. Okay, just moving to the next slide. So right here, these are the pieces of a video surveillance network. Up top, you have your IP network cameras. You can also have, to the left, analog cameras. So the IP cameras here would then go onto the IP network, which would be the existing IP infrastructure where all your switches, your layer 2 devices, your routers, your layer 3, and other devices are, printers and workstations. So then on the network, you'll also have other devices, other workstations now that can view the different videos. So you can have a computer with a web browser. Typically you can view the cameras through a web browser, and these can be on the actual IP network themselves or on the internet remotely that you can view these. And then the other type of PC that would be on this system would be a specialized one with special software, which would have the video management software that could give you further visibility into what's going on and what you're recording. Another important piece here would be your NVR or your DVR, so your network video recorder or your digital video recorder, and that would sit somewhere on the network wherever it makes sense, maybe at the central office. So now if you're using the analog cameras here, the only thing you would add that wouldn't be required by the IP cameras would be the video encoders here. So this is a standalone version, this is a chassis mounted one. These would be required to convert the analog over the IP network. So just going to the next slide. So for network camera options, there's two types, essentially. There's fixed and PTZ. So the fixed type, that's a traditional camera design. They've been around for a long time. It has a set viewing angle, and typically they're pointed in an axis way. It's popular to have them in doorways or garage doors, loading docks, that type of place, a gate entrance, because there's no need to do any movement there. And then you've got your PTZ version, which basically essentially allows you to take the lens and move it around. You can pan it across left and right and move, so if something needs to get your attention that you can't see, you can move over to it and zero in on it. And you can also go up or down, so you can do tilt. And then you can zoom in if you need to as well, so there's some more functionality there. And then both of these fixed and PTZ cameras have an option to have a dome. So with a dome camera, with both of these, the advantage is that you can't tell where the lens is pointing. Even though you might have a PTZ camera and a fixed camera, you never know exactly where it's pointed, so you don't know if it's pointed at you or not. So it's a bit of a deterrent. And also, having a dome, even if the lens doesn't move, it provides protection from the elements. So if you're mounting these outdoors, or if it's indoors, if it's a hazard environment like a factory or something like that, it'll give you a little bit extra ruggedness. So just moving to the next slide. So now that we have the different network camera options, we can look at the actual software, the compression types that go on with these cameras. So the longest form of video stream is called a MJPEG, which is a motion JPEG, or Motion Joint Pictures Experts Group. And what that is it's like cell animation. It's been around for a long time. It's just traditional. It's like page flipping. So each frame carries over, and if you're doing 30 frames per second, there would be 30 unique images that would then could be flipped and would provide motion. The next one would be MPEG-4, which is the same format that you use on DVDs. And it's interesting. It's a bit of an advancement on MJPEG in that it only captures the differences. So if you look at these three frames here at the bottom of the screen, there could be a person running towards a house. So even though the house is in the picture all the time, it doesn't move. The house is static. It will only transfer the motion and the animation of the man or the person walking or running towards the house. So it doesn't actually have to take every piece of information. So the advantage here is that you have less storage space. So you still get the same more or less performance and results that you get from Motion JPEG, but you just don't have to use as much storage on your hard drives or wherever you're storing your information. And then the last one, the newest compression type is H.264. That's the latest standard, and what that advances in is it's compression. So it reduces storage by 50-80%, and storage can be costly. So that's a definite advantage of utilizing that compression type. So just moving to the next slide. So when you're looking at the two types of technology, IP cameras versus analog, you need to know the differences. So with analog, it's an older technology. It's been around, but it's mature, and it's been proven itself, and it works well. And it's still advantaged. They've done studies, and it's still very advantaged to have these types of cameras for small indoor deployments. But when you deploy them on a large scale, they can get costly, but they do perform well. The other thing with analog is that you have to control the cameras locally. Basically, you're subject to, you have to have special cable to run to the cameras, special CCTV cable, and that's not available anywhere. It's typically restricted to the premise of where the cameras are, so you have to control them locally. And because you're not converting anything, you're straight taking an image and recording it. You have slightly better images with analog versus IP because there's no digital, analog to digital conversion. So with IP cameras, the advantage that they have is, the huge one is cost. Because most companies already have an existing IP network, you can take advantage of that existing infrastructure and deploy a camera and just attach it to a switch, just like you would a computer or printer or any other network device, and it's that simple. You just find it an IP address and make sure it's on the same network as yours, and you've got visibility. And the other advantage that's huge is because of the Internet, you can leverage the power of the Internet and the remote access capability, so you can basically view any camera anywhere on the Internet that you have connection. So if you have your, a public IP that you have available to get into the camera, then you can view it. So you're not limited to anything, just being physically located where the cameras are. Okay, so if you have a scenario where you have a bunch of analog cameras, but you want to take advantage of your existing IP infrastructure, you can transition. You can utilize your analog cameras on an IP network. The only thing is you need a special device called a video encoder. And what that will do is we'll take the analog images and convert them to zeros and ones and convert them essentially into digital. Very complex digital video streams, but that's essentially what it does. Actually, we had a customer, a municipal customer, City of Bellwood, who had a number of cameras. They wanted to maintain their investment in all these cameras, but they wanted to utilize them as efficiently as possible. So what they did was they bought a bunch of video encoders and used wireless, and were able to put these analog cameras, which were nice premium design and performed quite well. They put them on street corners and gave them more visibility onto the traffic that was going on, and they were also able to reduce crime. So they were able to secure their ROI on the cameras that they bought before. Okay, so now when we look at another important component of the network, storing the images that that the cameras capture, you can go with either a server or an NVR, DVR-based solution. So you can either have a standalone server that processes and it has huge storage capabilities, or you can go with a dedicated network video recorder, digital video recorder, which is essentially a server, but it's dedicated to recording video images, and large ones if necessary. So it's really a preference on how companies want to deploy. Typically, in our experience, we find that if a customer already has a server in place, they already have a system where they do a lot of storage, they may do network backups, or they may be archiving other data or documents or something like that. They may utilize that if they've got a high-performance server, just because they just want to reuse their equipment. But if it's a new deployment, it's a dedicated system that has a particular objective in mind, and typically they'll just have a standalone NVR, DVR preferred. So it's a specialized device. So it depends on what the customer is doing and which way they're going to go. Just moving, let me see here, I've got to make sure that I've got the right slide. Okay, so now then another key important component of the system would be video management software. So when you go out and buy a good quality camera, like an Axis or whatever you decide to use, they're very good cameras, but they typically don't have a lot of software that come with them. It's pretty basic. Typically, you can view with the software that comes with different cameras, or you might be able to do some recording. You maybe have some PTZ control if the camera supports it, but it's quite limited. I mean, most camera manufacturers are in the business of making cameras. They do that quite well, so that's typically what they focus on when you buy their product. So if you have a large camera infrastructure and you need to really, process some of the imaging that these cameras capture, you're going to need like a third-party management software platform. So, and what these guys bring to the table is a lot. There's a lot of different features that they have. I've listed them here in this slide. All sorts of things that can be processed. Like the slide says, you name it, it can be done. Some of the things that include would be the movement in zone feature. So you could set an area within a warehouse or something like that that's off limits due to safety reasons or something like that. And if anybody goes into that zone, the camera will trigger and it will create an alarm. You can also create tripwires in a sense where something will go off if someone enters a room. There may be a paint shop or something and it may not be safe to go in there. And if someone goes in there, it trips the door, and then someone says, "Oh, you got to go out of there because you don't want to inhale paint fumes or something like that." If it's a car plant or something like that. Another feature is tailgating, where someone could go through a gate and then someone could be behind them, drafting behind them real quick, and no one will see them. It looks like two people going by, kind of like radar, where there could be two things on a radar, but it looks like it appears as one. But it can differentiate between two different objects or two different cars. It might be two cars going through a gate. So there's a whole list here, all sorts of stuff. Asset protection, making if there's an obstacle in a road, you could have cameras out in the city, and if a telephone pole falls down after a storm, the public works team could be aware of it right as soon as it happens. They can go out and clear the obstruction to keep traffic flowing. You can also take all of these third-party camera software companies also have forensics, so that the images are time and date stamped. So if you need to do an investigation or assess what happened when an event happened, you can use these forensics for later retrieval, and they're actually admissible in court if you had to go to an insurance company or something and say an event happened at a certain time. We had an application in a warehouse where there was a car manufacturer that had a lot of robots moving around, and because of that, there could be a safety issue. So they had cameras in zones so that if anybody moved in that area, the cameras would trigger an event. So the security could let them know that to tell people that they can't be in that area, they have to lock the doors or whatever. So having this software can help make sure that people's safety and that things are going okay within a company.